Resistors are the most fundamental and commonly used of all the electronic components, to the point where they are almost taken for granted, but they play a vital role within a circuit. There are many different types of resistor available for the electronics constructor to choose from very small surface mount chip resistors up to large wire wound power resistors. The principal job of a resistor within an electrical or electronic circuit is to resist, hence the name resistor, regulate, or to set the flow of electrons, current, through them by using the type of conductive material from which they are composed. Resistors can also be connected together in various series and parallel combinations to form resistor networks which can act as voltage droppers, voltage dividers, or current limiters within a circuit. Resistors are what are called passive devices. That is, they contain no source of power or amplification but only attenuate or reduce the voltage or current signal passing through them. This attenuation results in electrical energy being lost in the form of heat as the resistor resists the flow of electrons through it. Most types of resistor are linear devices that produce a voltage drop across themselves when an electrical current flows through them because they obey Ohm's law, and different values of resistance produces different values of current or voltage. This can be very useful in electronic circuits by controlling or reducing either the current flow or voltage produced across them. We can produce a voltage to current and current to voltage converter. There are many thousands of different types of resistor and are produced in a variety of forms because their particular characteristics and accuracy suit certain areas of application, such as high stability, high voltage, high current, or are used as general-purpose resistors where their characteristics are less of a problem. Carbon resistors are the most common type of composition resistors. Carbon resistors are a cheap, general-purpose resistor used in electrical and electronic circuits. Their resistive element is manufactured from a mixture of finely ground carbon dust or graphite, similar to pencil lead, and a non-conducting ceramic, clay, powder to bind it all together. The ratio of carbon dust to ceramic, conductor to insulator, determines the overall resistive value of the mixture, and the higher the ratio of carbon, the lower the overall resistance. The mixture is molded into a cylindrical shape with metal wires or leads are attached to each end to provide the electrical connection as shown, before being coated with an outer insulating material and color-coded markings to denote its resistive value. Film resistor, the generic term film resistor, consists of metal film, carbon film, and metal oxide film resistor types, which are generally made by depositing pure metals, such as nickel, or an oxide film, such as tin oxide, onto an insulating ceramic rod or substrate. This method of manufacture allows for much closer tolerance resistors, 1% or less, as compared to the simpler carbon composition types. Metal film resistors have much better temperature stability than their carbon equivalents, lower noise, and are generally better for high-frequency or radio-frequency applications. Metal oxide resistors have better high-surge current capability with a much higher temperature rating than the equivalent metal film resistors. Another type of resistor, called a wirewound resistor, is made by winding a thin metal alloy wire, nichrome, or similar wire onto an insulating ceramic former in the form of a spiral helix similar to the film resistor above. They are also able to handle much higher electrical currents than other resistors of the same ohmic value with power ratings in excess of 300 watts. These high-power resistors are molded or pressed into an aluminum heat sink body with fins attached to increase their overall surface area to promote heat loss and cooling.